Good morning. It's my fault today because I said I would do an object lesson on the flood, and we're sort of opening the fountains of the deep here today. The thing that's funny is, though, I got stuff on my coffee cup. Ick. Um, this would be like at the end parts of it. This isn't even anywhere close to what the worst part of the rains would have been. This is absolutely nothing. I mean, and we need it. We we really need the rain. We are over. Usually, what Denise and I were talking about on the way in today, our area, we usually get about 36 inches of rain across the entire year, and it's pretty well even all year round. We don't have a dry season and a wet season. It's just about 3 inches every month. There's a couple months that are like 3.5. There's a couple months that are like 2.5. But they're pretty well 3 months every month, 3 inches every month. Over the past 18 months, we're down by 15 inches of rain. So we're down almost just about an inch a month over the past year and a half. So yeah, we're down just a touch here. So this is good. I mean, it hasn't been like really pouring rain, but it's this good soaking, and this is going to go down into the ground and not just run off. So it's a good thing. Yeah. Yep. Absolutely. So is it just me? Memorial Day weekend is always crappy like this? Last year was nice, if I remember. But usually it's not exactly the warmest weekend. I mean, it's sort of the unofficial start of summer, but we're still only in sort of a little beyond mid-spring. So it can still get a little cool. Just a quick update from last week. I am going for that second round interview, second round. I had my second round interview for the genius position. It went really well. I feel it went really well. You do an interview and you come out of it and you either think, yes, I feel really good, I answered the questions well, or you think, I wish I had said, you sort of start second guessing yourself. I didn't feel that way. I felt good. Wednesday, I find out feedback and next steps as to whether I go on to third round. If you go on to third round, that's the interview with our market leader. And pretty well, you get to that level, unless you really bomb that meeting. So I'll find out on Wednesday. So keep that in prayer if you would. So today we are continuing on with the flood, and we're finally going to get back to the Bible. I want to get out of that earth science textbook and sort of get back to our biblical account here and start comparing and contrasting what the biblical account and the hydroplate theory have to say about what we see. And again, what's so interesting is what we're trying to do is to look at what geological features do we see on the earth today. The secular explanation is long-term evolutionary process, plate tectonics, whereas we can look at the flood account and have all those exact same features, those exact same observations can match a totally different explanation. There is a very different start point, and that's what we're going to be sort of looking at here today. So again, the neat thing about the hydroplate theory, which is relatively new as a real scientific theory versus, well, this is the creation account. The hydroplate theory addresses two major issues that the plate tectonics theory doesn't. Number one, it aligns with the biblical account, which, of course, that's our prime source here, is that the biblical account of what happened with this worldwide flood. And it also addresses the shortcomings of plate tectonics. And there's when when you've got a scientific theory that does that, it doesn't just say, this is why I think I'm right, but this is also why the other one is wrong. That becomes so, so incredibly powerful. And I think I had mentioned before with Newton's laws of motion and laws of gravitation, those things help to show not just why the sun-centered arrangement of the solar system, sun in the center with the planets going around the sun, it not only showed why that one was right, but it also showed why the Earth-centered system, the one that we had held for so long, why that one was wrong. That's what made Newton's work so powerful. And that's the same thing here with the hydroplate theory. It addresses many of those shortcomings that we saw in plate tectonic theory. There's aspects of plate tectonics where they're like, okay, well, there's this process that's going on. We're not exactly sure why it's doing that. The hydroplate theory addresses that. And again, it was developed in the 70s. It's relatively new as an idea. It is a young Earth model. Okay, it is a model that is young Earth and creation Bible based. So we're looking at that 6,000 to 8,000 year old Earth mindset, and the fact that the Earth is young. We're not looking at this extended evolutionary period with plate tectonics. So what we have to sort of do is a little bit of going back to just like we did with plate tectonics. We're going to address the same issues and then look at where these things tie together with the Bible. And we start with the Earth's structure. And the current structure of the Earth, I'm not denying the current structure of the Earth. That's important to realize. The current structure of the Earth is the current structure of the Earth. But that doesn't mean it's been that way all along. And the Earth's structure pre-flood was totally different than the Earth's structure today. All right? The Earth has changed significantly. The flood was and again, sort of harping back as we've looked at this multiple times before, the flood was not just 40 days and nights of rain. That's that overly simplified little kid version of Noah's flood. Oh, it rained for 40 days and 40 nights. No, this was a fundamental restructuring of the entire Earth system. The present structure, as we looked at before, this idea of the Earth being a layered ball with a really thin, solid crust that's solid and cold, and then the hot, soft mantle, the hot, molten outer core, and the hot, solid inner core. That is the current structure. Again, not denying that. That is perfectly fine. But that's not the way the Earth was created. Let's go back to our current crust, because a lot of this is going to get addressed. The Earth's crust is made up of two different materials, two different types of rock. One is called basalt. Basalts are what the ocean floors are made of. Right? The bottoms of the oceans are made of this material called basalt. And basalt is an igneous rock, meaning it's of volcanic origin. It was molten and it has solidified as it cools. So basalts, the ocean floors, are igneous type rocks. They were molten. The continents are made of granite. Now, granite's kind of funky. I don't go into a lot of the really technical details of it. It's usually described as an igneous rock. It's not. It's not an igneous rock. It's a mixture of multiple materials. Granites are made up of 4 or 5 different minerals that all have different melting points and all have different densities, all right? The more dense the material is, you think about a bottle of Italian salad dressing. The most dense materials are the chunks of garlic and spices and all those kind of things. And they sink to the bottom. And then the next dense material is the vinegar, that sits down toward the bottom. And the least dense is the oil, and it sits on top. And if you let a material, a liquid material, just sit like that, gravity will make it self-separate. Heavy materials sink to the bottom, light materials go to the top. That was one of the other things in the book and the video that I'm using for my source material. What's so interesting about it is that the theory that is the hydroplate theory, and as we go through, you'll hear me keep saying this, the driving force for the hydroplate theory is one thing and one thing only: gravity. The force of gravity is what literally causes everything that we see in the hydroplate theory. As opposed to plate tectonics, where, okay, so we've got these convection cells that are in the mantle. Okay, cool, convection's fine. Hot material rises, cold material sinks, great. Why did it start? Why is it there? Why is it not there? There's a lot of things within plate tectonics theory that you're looking at, different processes and different things like that. And in many cases, what a geologist will say, well, this is happening through a process that we don't quite completely understand. The hydroplate theory is driven by a process we very, very, very easily understand. Gravity. Gravity. Which is what's so cool about it. And granite, here's an example of that gravity issue. Granite usually is described as an igneous rock. It's this mixture of multiple materials. They each have different melting points. Now, granite should not exist, and we can't make it. Basalts, no problem. No problem. You take the rock, in a laboratory, you take the rock, you heat it up to 2,000 or 3,000 or 4,000 degrees Fahrenheit, it melts, you let it cool, you get a solid rock. And wow, look at that. The stuff we make in the lab and the stuff that we pick up from the ocean floor look pretty similar. Great. Granite doesn't work that way. Basalts are igneous rocks, and they are, here, this is our map of the Earth again. The basalts are on the ocean floors. The continents are made of granite, and granite is very slightly less dense than basalt. That does fit with our plate tectonics thing of the continents sort of floating because they're less dense. But what's interesting is, go back one. If you look at the basalt as a material, it's sort of, the scientific term is that it's homogeneous. It's the same all the way through. Granite, and I'm ringing here, granite's all speckled. And the speckles are different materials, different minerals. Now, if granite was igneous, if it was, if we melt that rock and then let it solidify, gradually cool and solidify, it's going to do just like our bottle of Italian salad dressing. The heavier elements or the heavier minerals are going to sink toward the bottom. The lighter materials are going to rise toward the top. And you're going to get a layered or a stratified kind of material. Instead, we get this crystalline material, these crystals of different materials with different melting points, so they should be solidifying at different times as the cooling process happens. You can't make this in a lab. They haven't been able to reproduce what's the formation process, what is the geological process that makes granite. Can't figure it out. We can't figure it out. We don't know what it is. Biblically, what was the Earth's original structure? Well, let's go back. The Bible actually describes the Earth as being a surface with a deep layer of water, the fountains of the deep, a deep layer of water below the surface. Wow, look at this. What have geologists found? Salt water 6 to 8 miles below the Earth's surface. Where'd that come from? Well, it's soaked down. Not quite. Also, about 10 miles down, they have found areas about a mile thick, pockets of very salty saltwater sediments, 10 miles underneath the Earth's surface. Those are the remains and the remnant water from the fountains of the deep. Water cannot penetrate more than 5 miles below the surface. Why? There's that word again, gravity. Gravity is pulling down on the rocks that make the surface of the Earth. As it pulls them down, it creates more and more and more and more pressure. And eventually, depending on the material, there is a depth in that particular material where you cannot have cracks. Cracks just can't happen. Gravity pushes the material together. The pressure is so great, you cannot form cracks in the material. For granite, that depth is 5 miles. Water, like now, it's raining. That rain, some of that rain, is going to soak down into the ground. And it can soak down into the ground, and it can go downward, but it can never, no material can soak further down into the earth, into granite, more than 5 miles because of that gravitational pull, squashing the material, squeezing those cracks together. If that's the case, where'd that water 6 to 8 miles below the Earth's surface come from, or 10 miles below the Earth's surface come from? It can't come from the surface. There's no way that it can come from there. So here's hydroplate theory. So that we've got the Earth's surface with this pocket of water underneath it. The evolutionary theory for the formation of the Earth is that you've got this cloud of dust and gas, and that the parts sort of gradually gravity starts pulling them together and squishing them together. And the chunks start lumping together and get bigger and bigger and bigger. And as the lump gets bigger, it's got more gravity, so it pulls in more stuff, and it's pulling in dust and gas and rock and water. And that's what forms the Earth's surface. Now, as those things collide, it heats up, and it makes that ball melted. So the light stuff, like water, float to the top. The heavy stuff, like nickel and iron, sink down toward the bottom. There's our iron nickel core, our iron nickel outer core, great, and the water floating up toward the top. Not enough water out there. So then they say, oh, so then after the Earth formed at some point later, the Earth got bombarded by comets. The best way to describe a comet is a dirty snowball. Comets are not solid rock, all right? They're balls of ice and rock and ice, water. And as they get closer to the sun heats them up. The ice starts to melt. That's what makes the tail that comes out from behind a comet. The Earth got bombarded by comets, and that's where all the surface water came from. That's what they say. But it doesn't match up with the observations. And it doesn't explain, if that's the case, it doesn't explain those pockets of water that are 6, 8, 10 miles deep in the surface of the Earth. Hydroplate theory does. All right, great. This is a nice theory. How does it match up, though, with what the Bible says? Let's look at Psalm 33:7. We're going to look at 4 different verses that actually describe exactly what we're talking about here. Psalm 33:7 says, He gathereth the waters of the sea together in a heap. He layeth up the depths in storehouses. The depths of water being deep underground. Psalm 24, 1 and 2. The earth is the Lord's, and the fullness thereof, the world and they that dwell within. For he hath founded it upon the seas. That looks like earth founded upon seas. Earth sitting on top of water. He hath founded upon the seas. He has established it upon the floods. The earth is sitting on top of water. That is exactly what the hydroplate theory describes, is what we see in Psalm 24. Psalm 136. Bouncing around here a little bit. Psalm 136, verse 6. To him that stretched out the earth above the waters, for his mercy endureth forever. The earth is above the waters. That's that layer of solid rock above a layer of water underneath it. And then Genesis 7:11, that comes from our flood account. Where did the water come from for the flood? Genesis 7:11, in the 600th year of Noah's life, in the second month, the 17th day of the month, the same day, all the fountains of the great deep. That's what we're talking about here. This layer of water that's underneath the surface of the earth. The Bible perfectly describes exactly what the hydroplate theory theorizes. The earth's surface was formed. God, when he created the earth, he formed the earth's surface over top of that layer of water. The whole idea of a supercontinent, yeah, it wasn't just a supercontinent. It was, the entire surface of the earth was just solid originally. The entire surface of the earth was just this solid layer of earth with this trapped layer of water about 60 miles down underneath that. And then God covered that layer of earth also with water. When the Genesis account uses the word water, it uses the word mayim, all right, in the Genesis account, talking about the waters. That word that's used is mayim. That word is translated water. Liquid water. Only. Not gas, not vapor, not clouds, not mist, not ice. Water. Like out there. Water. All right? There's some some secular scientists and even some biblical believers. Oh, well, that's the atmosphere. That's the clouds. Not yet. Not yet. Eventually, but not yet. That word there that's used, it's not vapor, it's not ice, it's not mist. When we look in Genesis 1, the creation account, and that's where being able to look at what the original word was. We always have to be really careful with the Bible because the Bible is a translation. We're translating a word from one language to the other, and that doesn't always come across perfectly. You've heard and by the way, it's sort of a myth, that Eskimos have like 500 different words for snow. No, they don't really. They don't have that many. But they do have a number of different words that describe frozen precipitation falling out of the sky. So do we. Snow, sleet, hail, those are all different words to describe things falling out of the sky. Well, Hebrew is the same thing. It's got different words for water, but the word mayim in Genesis 1:2, and the earth was without form and void, and darkness was upon the face of the deep. Think about that layer of water that is 60 miles down, covered by the earth's surface. That's going to be awful dark down there. All right? The darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. Not clouds, not vapor, And then Genesis 1:6, and God said, let there be a firmament in the midst of the waters, and divide the waters from the waters. Divide the waters from the waters? Well, the firmament is the earth's surface, all right? Water underneath, water above. Exactly what hydroplate theory describes. This, okay? We have the surface of the deep. That's the liquid water that's down here. That's this. That's the deep. And then this is the water, the liquid water that's on the top. And the material in between, all right, that's the Earth's crust, and that's granite. There's where, again, our account of what's going on here differs very greatly from the secular account. God created the earth, the granite. Granite is a miraculous material. We can't produce it. We can't make it. We have no idea how it was formed. God does. He spoke it into existence. That layer of material, the granite layer that is the solid crust part of the Earth's surface, that is the miraculous Earth's surface that God created. That's a miraculous material. Then we look in Genesis 1, 9, and 10. God said, let the waters under heaven be gathered together unto one place, and let the dry land appear. And it was so. And God called the dry land earth, and the gathering together of the waters he called seas. And God saw that it was good. In hydroplate theory, the mindset is that he separated in Genesis 1, we've got the description of God separating the land from the seas. And the process there produced shallow seas, not oceans like we have now, not 12,000 foot deep oceans, not 10, 15, 20, 25,000 foot mountain ranges, but relatively low mountain ranges, 2, 3, 4, 5,000 foot mountain ranges, something more Appalachian-like versus Himalayas, Rockies, that type of thing. Relatively low mountain ranges, relatively shallow seas. Totally different from what we've got now. Remember, one of our issues that the seculars would say is, how could a flood cover the entire earth? All right, I mean, how are you going to get water that's going to be deep enough to cover Mount Everest? Well, the response is, you're making the assumption Mount Everest was there then, and it wasn't. It didn't exist yet. The amount of water that we're looking at currently in the Earth's seas, you can cover the Earth's surface between 6,000 and 9,000 feet deep, depending on the estimates. Very easily could cover the Appalachians. The highest point in the Appalachian Mountains down in North Carolina, Georgia, is not quite a mile high. All right, Denver's a mile high in the Rockies. It's not quite a mile in elevation, about 5,000 feet. 6,000 feet of water could very easily cover those, no sweat. All those other processes, all those other things that we see, all right, are present day surface features, are produced by the flood and by the processes that happened after the flood. And again, that's where people, they're making the assumption that everything we see now is exactly the same way it's been for however long back in the past, and that's not the case. It's the assumption you have to make for the uniformitarian kind of mindsets. That evolutionary, that long-term process mindset basically says everything that we see today and the processes that we see today are the same things that have been going on back into the past. They're continued to occur into the future. And that's not necessarily true. We can have very catastrophic changes, catastrophic differences to what's going on. So here we go. Genesis 1:9. Let the waters below the heavens be gathered into one place, let the dry land appear. What we start to see within this layer is that there are some areas that are more dense, they're heavier. and they sink downwards. And that, when they sink downwards, it produces a hollow on the surface, and there's your sea. Well, if some parts sink down, other parts have to push up. Because if this is pushing down, it's going to pressurize this water. And again, there's another piece. When these parts push downward, the water that's down there has to be compressed into a smaller area, and it increases the pressure. Number one, it increases the pressure. Number two, it pushes the land up in other places. And we still have the mantle underneath. That's still down there. But we've got a much thicker crust with these pillars. Now, does that match up with what scriptures say? Yeah. Psalm 75:3. Let's look at the whole psalm, not just that piece. Psalm 75:3. One more page. I love when the pages stick together. Psalm 75:3. The earth and all of its the earth and all of its inhabitants thereof are dissolved. I bear up the pillars of it. All right? Setting the earth's pillars. That's these structures. And then again, in Psalm 33:7, we saw that before, where he talks about he lays up the deep in storehouses. We've got deep water pockets separated by the earth's pillars, as described in Scripture. So again, here's our initial conditions. Okay? Top part of the Earth's surface, 5 miles down, because of gravity and the pressure, the granite seals that rock to the point where no water from here can soak down below 5 miles. Interestingly, it works the other way around. The great deep that's down here, all right, almost a mile thick, none of that can get out either. There's no cracks in this section, roughly 55 miles deep. There are no cracks in that where any of this water can get out, where any of this water can get down. Why? Because of gravity. Gravitational attraction, compressing the rock, literally sealing it, sealing that water into storehouses, the great deep. All right? The major premise of plate tectonics is this idea of Pangaea, the supercontinent, all right? This giant continent that, for some reason, why all of a sudden did this process start that makes the plates start pushing apart? Don't have an explanation for that one. But their idea is it starts with this supercontinent. Whoop. I keep going on to that one, but you guys aren't looking at that one. We've got our supercontinent that's before plate tectonics and seafloor spreading. The plate tectonics starts the mid-ocean ridge. That starts pushing the continents apart, all right? That was sort of the initial observation that brought about the concept of plate tectonics. But does it fit? Does it really fit? No. I can force a jigsaw puzzle to fit, all right? I get that little wooden mallet and whack that sucker in there. But it doesn't mean the picture is going to work. It doesn't mean it's right. Just because I can force the pieces into that spot, it doesn't mean that it's right. You have to look at not just the fit, but also the picture. And that's what we've got here, because there's Pangaea, however you want to pronounce it. Well, a couple of interesting questions in this image. Number one, I did it again. I'm going to be honest with you. I am not used to presenting with a audience screen here and a me screen back there. I'm not used to that. I'm used to looking here, but I know you can't see that. I'm just not used to that. Here's one big problem. Here's North America, okay? Where'd the rest of Mexico go? And Central America, where'd all that go? It's sort of missing. The fit of Europe into here is not really all that good. This is the other one that's really kind of funky, that you would never get. Wow, doesn't South America and Africa fit together so nicely? Yeah. The problem with that image is to make that image fit like that, you have to take Africa and shrink it by about 35% to make it fit like that. Here's the other problem. If what we're looking at is our mid-ocean ridge being here-ish, and everything is sliding apart, cool. North America's got to slide and rotate counterclockwise to get to its present orientation. This is the border, roughly, the border between the US and Canada, which is an east-west line. That's not really east-west here. You've got to sort of tilt, you've got to rotate North America counterclockwise. You've got to rotate South America clockwise. You got to do the same thing with Africa. You got to rotate Africa counterclockwise to bring Ethiopia and the Horn of Africa, to bring that up northward. You've got all the missing parts of Mexico and Central America. Doesn't work very well. But there's a much better fit. There is a jigsaw puzzle fit, but it's not continent to continent. That jigsaw puzzle fit is the mid-ocean ridge. If you slide the continents over to that mid-ocean ridge, they fit together really nicely. And what is the mid-ocean ridge? According to plate tectonics, it's where the hot material is coming to the surface and it's pushing the plates apart. In hydroplate theory, that's the crack. That's where the fountains of the deep were released. Along that crack, along that seam. It's about 45,000 miles, like the seam of a baseball, that is the origin point of the flood. That's where the water came, the overwhelming majority of the water came from the bursting open of the fountains of the deep. All right, so here's our Earth, and here's our mid-ocean ridge. Now, one thing to keep in mind is that parts of the mid-ocean ridge, because remember, after the flood happens, the mid-ocean ridge cracks open, the continents are sitting on top of water, and they slid. It provides a mechanism for how the continents move. The continents are sliding over top of this layer of water as the material is blowing out of the fountains of the deep. And as North America slides westward, part of the edge of North America runs over top of this western part of the mid-ocean ridge in the Pacific. That's why the Rocky Mountains here look very different from the Andes. The Andes, South America is not running into a mid-ocean ridge. So you get that buildup as the, sort of like a snowplow pushing snow, you get that buildup of snow in front of the plow. Well, you've got a buildup of material in front of South America as it's sliding sideways. But here, North America, you've got that buildup of material and running on top of the mountains caused by the mid-ocean ridge in the Pacific. There it is. There's our baseball scene. There's our baseball scene. Now, we're going to look at a couple of things next week. A couple of things to take a look at and to try to say, well, how well does hydroplate theory really work and tie in with what the Bible says and everything else? And we can figure out that little X I've got up there in Siberia, that's where it started. That's where it started, right there. That's the initial crack. When God burst open the fountains of the deep, it started right here. And we get that by looking at the distances and that other little piece that plate tectonics can't explain. Go back to my picture without the line. Okay, plate tectonics, explain this one, right here. You've got a mid-ocean ridge going this way, you've got another mid-ocean ridge this way. If it's got this convection current going on from underneath that's pushing the plates apart, how come this comes up here like this and goes poof and stops right there? Why does it stop right there? Because that's where one crack ran into another one. We're going to look at this next week. Crack starts here and propagates in both directions. All right? It moves in both directions, goes outward in both directions. Tension cracks in granite move at 3 miles per second. So if this crack starts here, you've got this, by gravity, you've got this massive amount of pressure in the fountains of the deep. God causes the crack. God says, okay, flood's going to start now, right there. He hits it with his cosmic hammer and breaks the crust all the way down to the fountains of the deep. They start bursting out. It causes tension in that plate. The plate starts to crack, and the crack starts to run. Just like when you get a crack in a piece of glass, and that crack runs through the glass, same idea. And it goes in both directions. Because this is flat as opposed to a globe, this goes up across the Arctic and comes around here. So this is actually connected. All right? Goes this way, goes this way. At that 3 miles a second, this crack comes around, and goes past here before this crack does. This crack comes around, hits the existing one, and stops. The crack stops because there's already one there. It makes absolute sense. And plate tectonics can't explain it because in this area right down here, what they say is this is going outward and outward this way. It's going outward and outward this way. So that means in this section right in here, you've got one plate going this way and you've got one plate going this way. That means there's plates pushing against each other, and what we should have where two plates collide, we looked at this already, what do we get where two plates collide? Mountains. I don't see no mountains right in here, other than the cracks, the mid-ocean ridges. How do they explain it? They don't. They can't explain that. They can't explain why this guy stops. We're going to continue on from here next week and look more at how the Bible describes the bursting open to the fountains of the deep and how that matches up with what we see, and then how that, so these fountains of the deep open up, the continents start sliding, start forming these features. We get the subduction, we get plates shoved underneath each other, but not because of really long, slow processes of plate tectonics, because of this explosive expansion of the continents and the continents sliding apart from the bursting open of the deep in the Great Flood. And then the other features that are formed, right? The mountain ranges, okay? The Andes, the Rockies, the Himalayas, right? How do those get formed? All right, the trenches, same thing. That process is good, but it's not the long-term plate tectonics process. And then what about things like the Grand Canyon and those features? Where do those come from? That's stuff we're going to look at next week as we continue forward with this guy. We're looking roughly, if I were to look at my calendar, today is the 24th. We leave on vacation the 21st of June. So I've got 3 more weeks basically 3 weeks to wrap up our discussion of hydrogen plate theory and seeing where that ties in with the Bible and describes what we see and matches up with our biblical description. Then we will be away on vacation the 21st and 28th. I've got a couple of really great videos that really, I mean, a lot of this stuff we can talk about and describe and say, oh, first we open the great fountains of the deep. Okay, cool. What if we could see it? Thank you, CGI and animations. We've got a couple of really great videos on that. And then we'll get back. I'll be back for the 5th of July, and then we'll be away for a week of summer camp. But we're going to then sort of go back and take a look at, on the 5th, we're going to look at, well, why did God have to do this in the first place? The easy answer is because men were evil. There's a bigger answer to that. And then once I get back from summer camp at the end of July into August, we're going to be looking at that interesting little set of verses at the very beginning of this entire thing. All right, the Genesis 6, 1 through 4, 1 through 5 verses. And start talking a little bit about the Nephilim. And where does that come in? Not just in the flood story, not just in Genesis, but literally all the way throughout the Bible, and even up to today. Nephilim, giants. Did you notice at Halloween what we're starting to see out there for so many different Halloween yard decorations? Those giant 30-foot tall skeletons and demons. Where did that come from all of a sudden? I don't think it's a coincidence. I don't think it's a coincidence. We'll get to that. That's that teaser. All right, let's close. Lord, we thank you so much for the day you've given to us. Thank you for the rain that we do so desperately need, Lord, and for the safety and travel as we come here today to be able to worship you. We thank you for attentive hearts, for attentive spirits, for giving me the words to be able to speak in clarity, Lord. I pray for our upcoming service that you'll be with Pastor with the message that he is going to bring to us. Give him peace, clarity,